Problem 5-84. Write the equation of an increasing exponential function that has a horizontal asymptote at y equals 15. Well, if you think back, when we were studying transformations of our parent graphs of different types of functions, we did study when we'd say y is equal to a times b raised to the power of x minus h plus k. And we talked about the different effects of the different parameters being our a, our h, and our k here. B is still our multiplier. So in this case, I'm going to go ahead here and just create a general exponential function. We'll say y is equal to 2 to the power of x. So in this case, my a is just 1. Okay, my h is 0, and my k is 0. When I take that and I graph it, I'm going to go ahead and just graph it on the calculator here. I'm going to go in here, I'm going to do y equals, and I'm going to say 2 raised to the power of x. There's my exponential function. And when I graph it, start out here, we'll see that I've got my exponential curve here. And notice it never ever touches our x-axis. It looks like it is, but it's getting closer and closer and closer. And if we look at our table, it'll show that it's getting closer and closer and closer to 0, but technically it never touches it ever. So if we think about that, if we want to, let's pull that out here so we can see that. So right now, let's say this. Let's say our horizontal asymptote is going to be the equation here. Well, it's never going to have a value here where y equals 0. So our horizontal asymptote is the equation y equals 0. So you know what? Let's move that over and make it look like I wrote it centered on there. Nice. All right. So if we want to move this graph up so that our horizontal asymptote ends up being at where y equals 15, then how would we have to change this equation? Think about it. Which of these values, or which of these parameters, a, h, or k, moves our graph up and down? If you said k, you're on the right track. Okay, this equation here is the same thing as saying y equals 2 to the power of x plus 0, because that's where our horizontal asymptote is. So if we take an equation here and we say y is equal to 2 to the power of x, and if we add 15 to it, it should translate our graph up 15 units. And let's check that on the calculator. So we're going to take our original function here, and we're going to have to add 15 at the end. Now we know that our scale here goes from -10 to +10 on the y-axis. So let's go ahead and adjust our window here. Let's move our y maximum up to, let's say, 20. That way 15 will fit in there. So let's hit graph. And you'll see here, now we're going to have a horizontal asymptote that runs right there where our y value is going to be 15. So I'll pull that one out here so we can have it on here as well. This one, remember, that horizontal asymptote, if we were to like draw it in here, it would run right along our graph, or actually our graph would run right along the asymptote there, but it would never actually touch it. So this is where we have a horizontal asymptote. At y equals 15, because it's 15 up. All these points have y values that are 15. So it said write the equation of an increasing exponential function that has a horizontal asymptote where y equals 15. This would be one example of a function like that. As long as you're adding 15 at the end here, or your k value, we should say, is 15, you're good to go. You could have a different kind of multiplier there, or whatever multiplier you wanted. All right, this is problem 5-84. Hopefully this helped you out. If you have questions, make sure you ask your teacher. Thanks for listening.